This text comparison shows two language models responding to the same prompt about UFOs. At the top, the standard model generates a refusal, insisting it cannot confirm any conspiracy. At the bottom, an uncensored local model bypasses guardrails completely, exploring the prompt without hesitation. When you type a sensitive question into a commercial AI, your request travels to an external server. The platform routes your data through their API, logs the query, runs it against their safety filters, and stores the interaction. You are trading your data privacy for access to their hardware. Today, we are going to bypass those external servers. Over the next 5 minutes, you will set up a fully unrestricted private language model running entirely on your own personal hardware. True data privacy is impossible on a cloud-based architecture. To secure your interactions, you have to move the execution of the intelligence to infrastructure you physically control. To understand how we get an uncensored model, we need to look at a process called abliteration. This is the mathematical technique researchers use to remove built-in censorship from open-weight models. This diagram visualizes data moving through an AI's residual stream. Refusal behavior isn't randomly scattered, it's highly concentrated along a single measurable direction. Developers apply weight orthogonization to mathematically subtract this specific refusal vector, erasing it completely while leaving surrounding neural pathways untouched. This targeted extraction means the AI literally forgets how to refuse a prompt. It retains its general reasoning, its vocabulary, and its logic. Censorship is an engineered modular appendage. By severing that specific vector, the end user reclaims full access to the underlying logic engine. This hardware matrix chart maps the exact system limits needed. Your primary bottleneck for running these local models is system memory. You need 8 gigabytes of RAM for a 2 billion parameter model and 32 gigabytes for 30 billion parameters. To fit models into consumer tiers, GGUF quantization shrinks weight files by a factor of 4, allowing complex AI to run efficiently on laptops. With the hardware math done, we need software to orchestrate the processing. While terminal engines like Llama work, a graphical interface makes deployment smoother. Step 1. Go to the LM Studio website. Download the correct installer for your operating system and run the setup. LM Studio operates as your bridge. It handles the complex command line executions in the background and provides you with a clean, familiar chat interface. You don't need to write code to deploy sovereign AI. You simply need to match your machine's available RAM to the right GGUF file size. In LM Studio, search for Abliterated 7B GGUF. Filter for Llama 3 or Dolphin models, paying close attention to the file size. Exceeding your physical RAM capacity will crash your system. Stick to the established hardware limits. Click Download on a model that fits your hardware. The GGUF file writes directly to your local drive. In the Chat tab, select your new obliterated model from the top dropdown. The RAM indicator fills as LM Studio unpacks weights into system memory. Type your prompt into the chat window and hit Enter. The text generates token by token. Now physically unplug your Ethernet cable or turn off your Wi-Fi and submit another prompt. The AI will continue to generate its response. Watching tokens generate without a network connection proves the system works. You have successfully severed all ties to corporate monitoring APIs. You now have a fully operational, unmonitored language model running directly on your desk. By removing the hard-coded moral compass of a commercial AI, the entire burden of responsibility shifts. Without centralized safety filters blocking your requests, you are solely accountable for the outputs you generate and how you apply them. The decentralized ecosystem is growing fast. Swap to specialized coding variants, logical reasoning engines, or creative writing tools, all using the exact same workflow. The future of AI safety will be governed by individual human responsibility at the edge of the network. Check the description for direct links to tested GGUF models, and subscribe to the channel for advanced local AI workflows.